Good evening, everyone. In the last videos, I think we discussed very clearly about this heap data structure, sir. Okay, like how you can able to represent these heaps and how you can able to create that heap. I think we have not covered in detail information, but what is the outline? What is the outline? How to insert an object? That outline I explained very clearly. So in our last video. Now we will see this particular program with respect to coding, sir. Okay, we will write a small piece of code, okay, to explain the concept of insertion. Okay, so if you want, let us revise for a few minutes. What is a insertion process? There are two steps are there. For example, if I want to insert an object called one into the existing what you can call existing heap. For example, consider here the existing heap is something like 2 and followed by 3, and here we have 4 is there. Okay, so and here I want to take a 5, and here I have 10. Like this, some content is there, sir. In this, I want to insert a new object called 1. Where we have to insert, you need to add always to the next vacant position, and you have to check with its parent. Since it is nothing but a min heap, right? Since it is nothing but a min heap, so all the values which are present in the parent should be very less when compared with its children. So now compare these two. Is 1 is less than 4? Yes. Then you have to interchange these two values. So in this place you are going to get 1. In this place you are going to get 4. Sir, up to this level it is satisfying our principle. So but what is the next level, sir? You have to compare this 1 is there, right, with this, but 2 is the maximum when compared with 1. So 1 less than 2 is also satisfied. Again try to interchange these two values, so that here we are going to get 1 and here we are going to get 2, so that your tree will become so 1 3 and then 2 and then 4 and then 5 and then 10. Like this we are going to get. This is nothing but the standard approach which I explained in the last video. What is the first step? We have to add the node at the last, I mean vacant position, and we have to fix this particular heap, sir. This process I explained very clearly in our last video. Now what we have to do, I need to implement this program. Okay, I will take one Java program for this purpose. Okay, let us take a new Java file. So I want to select from 7 p.m. folder is there. No, let us take a test folder within this. So test.java class I am taking. Okay, so I am removing all this, and I will create a separate class called heap. I will create a separate class called heap. I am taking a heap class. Otherwise, better I will do within the test class. So compulsory you have to declare this class as a static class heap. Here I will write implementation for this. Okay, sir, main method I will discuss tomorrow. Just insertion alone I am explaining. Sir, I will create one array list. I will create one array list to hold the values of integers. Let us take that array name is nothing but array list. Like this we have. Okay, so next and after that I created one simple array list to hold the object. Sir, why we are taking array list? Because we can't give guarantee for the number of elements present in the heap, right? So if we take array, we have to fix the size. So here I don't know how many objects I am going to insert and how many objects are there. That's why I'm going to take array list. Next, what we have to do, we have to write the functions. My first function is public void add function. This is our requirement. Sir, we have two steps are there, right? First step is what? We have to add the data at the end. We have to add the data at the end. What is the second step? Second step is nothing but we have to fix the heap. We have to fix the heap. Sir, here arr dot add of data. That's all. Simple step, right? Arr dot ARR dot add of data, if you provide, this data will be added at the ending always. So next what we have to do, you need to identify. For example, if you take our previous example itself, so there I have taken here 2, and its left subtree is nothing but 3, and in the right subtree we have 4 is there, and for this left subtree is nothing but 5, and the right subtree is nothing but 6. Let us take this is for our example. So in this case what I am doing to do, I have to insert 1, where 1 will be added at the end. So if you take array list, this is my array list. Level wise the data is stored in this array list. So first, in the first level we have 2 is there, and in the next value 3 and 4 are there. In the next value we have 5 and 6. So 0th location, first location, second, third, and then 4. So 0th location, first location, second location, third location, and 4. Now after adding this, if you want to insert any object, where it has to be inserted, so compulsory it is going to be inserted here only. In 5th location it is going to be stored. Yes, so I will store this data in 5th location. I will store this data in 5th location. The data will come 1. Like this we have. Now what is the next step? So in which location we have added, in which location we have added, it will become child index, and try to identify the parent index. These two we have to calculate. How to get child index? Last index, right? That's why I'm going to take integer child index will become, so ARR dot size, total array list size minus 1, because last element. How to calculate parent index? In the last video I explained. What is the formula for calculating parent index? Child index minus 1 by 2. Sir, here what is the child index? Ci minus 1 by 2. Like this I am going to take. Now what is our step? So here you can able to see child index will become 5, sir. What is its parent index? 5 minus 1 will become 4. 4 by 2 means 2. Sir, correct, right? Now we have to compare these two locations. Sorry, I think a child location, child index is 5. Yeah, array size minus 1 by 2. 5 minus 1. 5 minus 1. 4. 4 by 2 means yes, correct. Like this we have. Now you have to compare. Sir, how you can compare? Is this particular child index value is less than parent index, means we have to perform swapping, and we have to do this repeated step, right, till the top. That's why I'm going to write a while loop. What is that while loop? So that while loop is nothing but, so in that array list, try to get a child index value. If this value is less than, in that array index, try to get a parent index. So if both are less, that means swapping is required. How to get the swapping? I will store that child index in the temp. So ARR dot get of child index I am getting, I will store it in a temp. Then ARR dot set of in the place of child index. So try to get the data which is located in parent index. In the parent index, whatever content is there, observe carefully. So temp is equal to ARR dot get of child index. What is the child index? 5. So that is nothing but 1. And set of child index in the first position. Okay. What is child index here? 5, right? Content is 1. Sorry, content is 1, and the child index will become 5. So in the 5th location, try to get a parent index. Parent index is 2. So in the second position, whatever content is there, that will be updated here. Okay, sir, we have to set this temp to this location, right? How to do that? Very simple. Again, I am going to take ARR dot. So set, okay. So set of in the parent index, we have to hold a temp. So in temp, which value is there? 1. Parent index is nothing but 2. Here I am updating with 1. Perfect. And this process here you can able to see. So here you can able to see this process completed. Same step you have to repeat for this, right? How to change that? This parent index will become child index. How to get a change? How to get parent index? So your child index will become parent index now onwards. If you know child index, so you know how to calculate parent index. That's all right. This process we are going to repeat This is the way how we can insert a new element into the priority queue, sir. Okay, this algorithm it is going to follow internally. Can you please confirm everyone, is the concept is clear? Yes, I request everyone to please confirm. Is it clear, friends? Right. Sir, now I will keep this program as it is. I will keep this program as it is. So I will go for, okay, better I will take up to this. So now we have to talk about delete functionality. How you can able to do that deletion we are going to see. So deletion in heap, deletion in heap we have to discuss. So how to delete in heap? Let us see. Now observe carefully. I want to perform which operation, sir? Delete operation. How to do this delete operation? Very simple. Consider I have the root node as a 2 and its child will become 3. Okay. Next, its another child will become 4 and then its another child will become 5 and this another child will become 10 and its left child is nothing but a 6. Like this I have. So I want to delete the node. Sir, which node we have to delete? So So which node we have to delete? I think we have to delete the first smallest element, right? So in this, which one we have to delete? Second location. Sorry, the element is nothing but 2 because in the heap, in which order we have added in our previous cases in the examples, if you see, so we have added in different stages. Like we added 3 first, we added 4, we added 1, and we added the element 7. But which one removed first? 1, because so the element which is having highest priority. So in this case, the element which is having least value, that is ascending order. So if you take ascending order, the least element is going to be extracted first. In the same way, deletion also, which element you have to delete two, sir? But it is very difficult to do to delete this two. That's why the first step what we are going to do here is I want to swap. So first element and last element. I will swap this first element and the last element so that my tree will become 6 here. Okay. So then 3 will be there here. So next 4 will be there here. Next 2 will be there here. And here we are going to get a 5. And here we are going to get a 10. Like this we have. This is nothing but what we have here. Okay. Now what we have to do? Sir, we need to delete this 6. That's why. So, sir, we need to delete this 2. That's why I moved this to the last. Why? Because deletion of last element will become very easy, right? How to delete? Because we have array list is there. On that we can call remove function. On that we can call remove function. So just by passing that value, which value we have to pass? That last location, right? How to identify last location? ARR dot get size minus 1. Get size minus 1. Sir, what is the size of this particular array list? 1, 2, 3, 4, 5, 6 elements are there. 6 minus 1 means 5. In the fifth location, whatever element is there, it will be removed from the list so that our target got achieved. So here we have 6 is there, and here the element 3 is there, and here the element 4 is there, and here we have 5, and here we have 10. Like this we have some content. Sir, perfect, it is good, no problem at all. But is it satisfying my heap properties? No. Then we can't fix that heap because it is not one level operation. Every level we have to check. That's why there is one special operation is there called heapify. Heapify of I'm going to take a 0. So based on that I'm going to perform this heapifying, sir. Heapifying in the sense it will rearrange all the nodes based on the priority so that the minimum element will come to the top. For every node I will take. because starting from this particular 0th location to remaining all the elements I am going to take. But how to do that process, I will explain step by step. Can you please confirm up to this how this deletion operation is going to perform? Is it clear for you people? I request everyone to please confirm. Clear up to this, please confirm. Yes, right. Sir, how we can able to do this sweep heapify function? We will discuss now. Observe carefully. Sir, here first I will explain a small structure, sir. For example, consider I have a node is there called 5 here. Okay, and its left subtree will become 3. Assume its left subtree is nothing but 3. Okay, and its right subtree is nothing but 4. Like this we have. So locations are nothing but consider it is 0th location, first location, second location. So in my array, okay, I mean in my array list, I have 3 elements are there like 5. So 3 and then 4. Sir, do you know how I am going to calculate this is here root node will become 0, right? Root node will become 0. Try to identify the minimum value among this. Try to identify the minimum value among this. Forget about this root. I will explain in the diagram. So we have to identify the minimum among this. Sir, we have 5 is there, we have 3 is there, we have 4 is there. Among these, which one is the minimum, sir? 3, right? Now wherever 3 is there, so try to interchange this element with its parent, so that your tree will become what, sir? So your tree is nothing but 3 will come here, and 5 will come here, and 4 will come here. That's all right. Our requirement got satisfied. Even if you want, you can cross check one more time. So completely, yeah, math dot minimum you have to use. Sir, completely now my this particular array list is already satisfying this particular priority queue properties. Okay, that is heap tree properties, it is satisfying. I think this small piece of code is very clear for you people how we are performing this heapifying operation. Of course, we have to repeat this process continuously for each and every node from root node. That means first 6 3 4 minimum value will come to the beginning. Then take this left subtree. Again try to calculate minimum value. It will come here. Like that we have to do, sir. Okay. I think you people got clarity how we can able to do this. Please confirm clear up to this everyone. Don't worry, I will explain the process. Is it clear up to this? It is a recursive process, sir. It is a recursive process. Okay, right. Sir, how we are going to do this process? Very simple. In this case, the root node location is nothing but 0, right? Assume. Sir, we have to identify its left pointer, left subtree node. I mean left subtree node, right subtree node. Okay. So what is a left subtree? How you can able to identify its index, left subtree index? So 2 into I plus 1, right? 2 into 0, 1. So similarly, right subtree. How you can identify? So 2 into I plus 2. So 2 into 0 will become 0. 0 plus 2 means 2. Like this we have. Now you have to calculate minimum among these. Sir, which values? We have 5 is there. That is nothing but I mean root node index, that is nothing but 5, and left subtree index is 1. In first location we have, so 3 is there. In second location we have 4 is there. So 0th location, first location, second location. Like this we have. Now what we have to do? Sir, I calculated minimum value. Your minimum value will become 3. Try to identify minimum index also. What is the minimum index? 1, right? My minimum index is 1. Now what we have to do? You have to swap this minimum index with root. Root is nothing but 0. In 0th position, first index value will come. In this first index, we are going to get 0th index value. Like this, it is going to follow. We have to implement this in the form of coding, sir. So don't worry, I will explain this process by writing the code. Observe carefully. So which function we have to rewrite? We need to take public integer remove function I am taking. So how it is going to work? First we have to identify the data which we have to remove. Sir, the data which is available in the 0th location we are going to remove. At last we have to return that data. So next what we have to do in this? Next what we have to do in this? Sir, we have three steps are there. What is the first step? We have to swap first and last index values. What is the second step? Sir, we have to delete last element. We have to delete the last element. What is the third step we have to take? Sir, we have to perform heapify operation. Sir, in the case of swap first and last, okay, we have to swap first and last. As usual, we are going to store the value in the temporary variable like arr.get0 and arr dot set of which index we have to change. In 0th index, arr dot get of, so arr dot size -1, last element will come. So then arr dot set of, sir, in which position? Arr dot size -1, last location I am updating with temp. Yes, swapping of first location and the last location got completed. Next what we have to do? We have to delete the last element. Arr dot remove of, so arr dot size -1 comma that temp value. No, here we are not required to do that. Arr of size -1, last element will be removed. Then I have to call heapify function by passing 0 as the argument. Starting from root, it is a recursive function. It will call for its child indexes also. Like this process is going to be performed. Sir, where is heapify function? We have to write that function. Public void, so heapify function, which will take some index value. Based on that index, we are running the entire story. Can you please confirm, is the remove function code skeleton, is it clear for you people? I request everyone to please confirm. Clear, right? Sir, the return value will be the root. I mean, return data. Uh, no, no, no. Yeah, see, first, Vishal, here we are finding the element which is available at the root node. That means, if it is min heap, minimum element will be there. If it is max heap, max element will be there. That element we are storing in the data. Even if you swap this element, already we captured that data, right? So there is no impact. That will be removed at last. I mean, that will be returned at last. Meanwhile, we are going to do that swapping and we are removing that and we are going to perform heapify. At a time, we are going to remove only one element, right? That's why there is no issue. Got it? Yeah, we are returning the deleted element. That is our main agenda. Even if you see our previous priority queue, here you can see. So until your PQ is not empty, we are displaying the element at the top location. Compulsory you have to remove. Otherwise, you can't get the order properly. See, if you take any priority queue, in this priority queue, which is the minimum element 2, next element you can't give guarantee. Okay, you can't give guarantee. Maybe 3 may be present here, sorry, 4 may be existed here, 3 may be existed here. Order is not fixed. So it depends on the always topmost element, I can say the root element. Okay, so after deleting this element, compulsory you have to rearrange this structure. Okay, while inserting also we have to rearrange, but while inserting we are trying to insert at the end and we are doing that small operations. But whenever you are deleting, compulsory the entire priority queue is going to be unstructured. That you have to structure by using this heapify concept. Clear, Vishal? Right. Now, sir, let us take one simple example for performing this delete operation. I mean, this heapify operation, so that we will get clarity on that. Consider I have a simple tree is there. Okay, like 6 is nothing but a root element. So next, its left subtree is nothing but consider we have 3 is there. So its right subtree is nothing but consider 4 is there. And here we have 5 is there. Okay, so and here we have 10 is there. Okay, like this we have some elements are there. Sir, in this case, which element I want to delete? Okay, which element we have to delete here? Already here we have 2 is there. One second. Yes. So assume here we have 2 is there, and here we have 6 is there. So what is the first step that we are doing? We are removing this element, okay, by moving that position to the last. So 6 will come here, and left subtree will become 3, and right subtree will become 4, and its left subtree will become 5, and its right subtree will become 10. Like that we are going to get. So what is the next level operation here we are going to do? Sir, we have to delete this element. Here we are going to get 2, that 2 will be deleted. Okay. So after deletion of 2, so my parent will become 6, and here 3, and here 4, and here 5, and here 10. Like this we have. Okay. Try to identify the locations. 0th location, first location, second location. So third location, fourth location. Even if you take this array, even if you take this array, so 6 element is there here, third element is there here, fourth element is there here, fifth element is there here, 10th element is there here. 0 1 2 3 4. Like this we have. Sir, now what is the next operation? We have to do this heapifying. Sir, how to do that? First phase I am explaining, listen carefully. So in the first, yeah, can you please confirm? Am I audible? Is my voice is clear now? Am I audible? Is my voice is clear now? Yeah, right. Right, sir. Good. So here your I value will become 0. Your left subtree will become, yeah. So 2 into I, 2 into 0 will become 0. 0 plus 1 will become 1. Right subtree will become 2 into 0 will become 2. Sorry, 0 plus 2 is nothing but 2. Left subtree is 1. Right subtree index is nothing but 2. Now, what is your next requirement? I'm going to assume, I mean, we have to find out maximum index among these. So the value which is located in 0th location is 6. The value which is located in first location is nothing but 3. The value which is located in second location is nothing but 4. So we have to identify the minimum index among this. Okay. How you can able to identify? Assume the minimum index is by default 0. Okay. Minimum index is by default 0. Like that I'm going to consider. So then we have to find out the minimum index. So 6, 3, 4. Among these, the default value, minimum value is nothing but 3, and its index value will become 1. So your minimum index is nothing but 1, sir. Now you have to compare. What is that minimum index that we have? 1. This 3 we have to compare with root node. Is this 3 is less than root node? One second, one second. So minimum value is nothing but 3, and its index value is nothing but 1, right? Yes, its value is nothing but minimum index is nothing but 1. That is our requirement. Then what we have to do? We have to perform swapping operation. Which things we have to swap? Minimum index value we have to swap, and then index value we have to swap. Sir, my index is nothing but 0. My minimum index is nothing but 1. So these two positions we are going to interchange with each other. These two positions we are going to interchange with each other. Sir, same process again we have to repeat for step 2. So here we are going to get 3, and here we are going to get 6. So now what is the index value next time? We are going to pass index value as next minimum index value will become 1. Based on that we have to do. That means heapifying we are going to do this process. So here your left subtree will become 2 into 1. 2 plus 1 will become 2. Your right subtree will become 2 into 1 will become 2. 2 plus 2 will become 4. Is it correct? 2 into yeah, 2 into 1, 3 here we are going to get. Okay, and here we are going to get 4. So what is the minimum index value? I will take index value itself, minimum index. Then you have to identify the minimum index among this. So in the index 3, which value is there? 5. In index 1, which value is there? 6. In index 4, which value is there? 10. Like these three values are there. You have to identify minimum among these 3. Sir, which one is the minimum? 5. What is the location, sir? So here we are going to get 3. We have to swap these two, sir. We have to swap these two. So if the values are less, yes. So here we got, one second. Here we got 3, and here we got 6, and here we got 4, and here we got 5, and here we got 10. Now you have to interchange these two so that your values will become 3, and here 5, and here 4, and here 6, and here 10. So again, next we have to give this one as a minimum index. Sir, what is your index now in the third case? Sir, its value will become these two positions we have changed, right? First position and then third position. Okay, like this we got. Now your minimum index is what, sir? 3. For 3 again we are calling. Your left subtree will become 3 into, okay, 3 into I value is, sorry, 2 into I value is 3. 2 into 3 is nothing but a 6. 6 plus 1 is a 7, and your right subtree will become 8. Sir, you can able to see we don't have any index values in this array list, right, with this range. That's why the loop is going to be stopped. Like this we have to do. So for this we have to write code. Which is that code? Heapify code we have to take. Sir, how you can able to write? Integer, try to, already we have index is there, try to calculate left. So how to calculate left? 2 into index plus 1, and try to calculate right index. How to calculate? So 2 into index plus 2. Try to take minimum index. Your index, whatever you have given, is the minimum index. If sir, left subtree, I mean left index value is less than arr dot size, because every time you have to compare the size, and arr dot get of minimum index, whatever value is there, is it greater than arr get of left subtree? If it is true, then your minimum will become left, sir. So next, if right subtree is less than arr dot size, so and arr dot get of minimum index, is it greater than arr dot get of right subtree? Okay, here also we have to take left. So here we have to take right. Sir, if it is satisfied, then your minimum index will become what? Right subtree, right? Okay, fine. Then we have to calculate minimum among these three. I will write a if condition. So when you can calculate minimum, if your index value whatever you have given, if your index value whatever you have given is not equal to minimum index, because if minimum index and your indexes are same, what is the need to swap? Not required, right? Then integer temp is equal to, so arr dot get, okay, so arr dot get of index value, in which position it is available, that value I am going to store. And in that arr dot set of, I am changing the value which is located in index with arr dot get of minimum index. Similarly, so arr dot set of, in that minimum index we are going to hold this temporary value. Sir, after doing this, what we have to do? You need to call this heapify. I think in the if condition itself we have to call, because it is a recursive process, right? We have to call heapify for that minimum index. For example, if your main index is 0, so I got some minimum index. For this we called heapify. For this it will be called heapify. For this it will be called heapify. Like that it will call for heapify every time, sir. Have you observed? Like this we are going to do. This is nothing but how you can able to do this heapify concept. So I think how to insert an object, how to delete an object, algorithmic wise, these two are clear for you people, sir. Can you please confirm clear up to this? Clear up to this, please confirm. Right. So I think there is one special method is there called peak method. So no need to explain about that, because peak method is going to return the element which is always at root node. Can you please confirm? Just I am going to return arr dot get off. Can you please tell me what is the index of root node? Everyone, please respond. What is the index of root node? 0 0. Just we have to return that 0. That's all. Automatically it is going to be reset, sir. So this is nothing but how you can able. Now insert function is there, delete function is there, peak function is there. We can run the code, right? So just in the main method I have to write the code. Sir, how I am going to write code in the main method? Very simple. Oh, one more method is required. Can you please guess which method is required apart from these two? Insertion, deletion, peak. One more method is required. Can anyone guess which method is required to do this heapify process, or to see how this priority queue is working, or these heaps are working? We need some other method. No, not print method. Swapnil, you can see here we are not at all printing anywhere data. We are trying to access only from the beginning, I mean root node. We are not at all printing the data. Okay, sir, here you can able to see priority queue adding is there, getting the element at the top position is there, removing the operation is there. Is empty method is required. Without this we can't fetch the data, right? So public boolean, I am going to write is empty method, is empty method. So it is going to return true or false. But my question is, can you please tell me what logic I can write here to return true if my array list is empty, and what logic we have to return for that false? Can you please tell me the logic? Good, Vishal. Arr dot size is there, right? If it is equal to 0, it will return true, which says that my array list is nothing but empty. Otherwise, it is not empty. Now my requirement is nothing but observe carefully. So I'm going to take, sorry, 1 second. So what is the class name that we have taken? Heap, right? So I'm taking heap. So h is equal to, so new heap I'm taking. Okay. Then heap dot add of 3 I am adding. So heap dot add of 4 I am adding. So heap dot add of 1 I am taking. So heap dot add of 5 I am taking. Like this I added until your heap is not empty. Until your heap is not empty. So system dot out dot println of try to get the element which is available at the top position and try to remove the element from the heap, sir. Now I will execute this code and I will show you how it is going to work. So Java C I'm taking. So test.java code compile find. And when I'm executing the code, we are getting 1345. Is it coming in the order or not? Yes, this is the way how we can able to perform these heap level operations. And if you see for priority queue also, same output we got, right? For priority queue also, same output we got. But here we have not implemented priority queue. Directly we are using the existing priority queue concept. That means internally it is implemented by using heap data structure only. But here I implemented by my own. Okay. I think you people got very clear clarity about these things. Can you please confirm any doubts, friends, up to this? Yes, I request everyone to please confirm. Any doubts up to this? Right. So with this, I'm stopping today's session. So tomorrow also priority queues will become continued. There I'm going to discuss about heap sort algorithm, how you can apply. Okay. And Saturday, Sunday, yes, class is there. So the timings of this session is as usual from 7 to 9 I'm going to take Saturday and Sunday 7 p.m. to 9 p.m. session is there. Okay. There I will discuss greedy method, dynamic programming and divide and conquer. So time complexity, space complexity, and then red black trees. Okay. And AVL trees. These things will be covered in the next week. Okay. With that I will wind up. These things, yeah, these two things will be covered on the next week. These things, priority queue, tomorrow I will wind up. These three concepts, divide and conquer, greedy algorithms, dynamic programming, tomorrow and the day after, I mean Saturday and Sunday 7 to 9 I am going to take the special class. There I will cover. Okay, right, sir. Thank you. We will meet for the continuation tomorrow as usual at 7 o'clock. Okay, yeah, thank you guys. Sushant, please contact our admin team. They will provide the support for videos. Okay, please contact our admin team. Yeah, right. Thank you, guys.